In this video, I'm going to be showing examples of variable definitions and math operations using the Java programming language. For these examples that I'm going to be giving, I'm going to be going to the demonstration board right here and shows examples of actual code for these various operations. I'm going to start out here at the top of my screen. These are going to be some variable operations for integer and floating point data. Starting out, first of all, an integer definition. You start out with the data type int, then you give the variable name, like in my case int var, equals, and then you specify the value. Like here, int var equals 10. Next we have double, db var equals 20.0. Or like a common example here, double pi equals 3.14159. Now, right here, I've also included float, sum val, 10.5f. Important thing to note here is that in the computer programs, when you're working with floating point data, the double data type is considered the native data type for programming. And then float is a shorter version of the double. And when you're specifying the float data type, it expects you to put an F on the end of it like shown here in order so that it knows it's a float value instead of a double value. Floats and doubles are interchangeable, but because the float value has a smaller resolution, the computer program wants you to specify float explicitly if you use it. For the most part in your computer programs, you'll just have everything be the double data type and not even worry about it. Then below that, we have character definitions. First of all, here's an example of just defining a char, choice, equal to the letter A. This is if you're going to have a variable that's just one single character. And then here's some examples of if you're working with strings, where you'll use string, give the variable name, equals, and then you will put the string in quotes. Another thing to note is you'll see the character uses single quotes and the string uses double quotes. That's the nomenclature used by the Java programming language to distinguish between characters and strings. Then finally down here we have a Boolean, and I called it in condition, and I set it equal to false. Boolean can only be set to either true or false. Now going on, when you're working with numeric data types, as I showed in the first module video, your data types can be set up as either integer or floating point values. But what happens when you want to use integer and floating point values together in math operations? Like here, I say integer hours worked equals 41, double pay rate 11.75, and then gross pay is equal to hours worked times pay rate. Well, anytime that you do mixing of data types, integer and floating point, the result will always be floating point. So like here, gross pay will be double. And then if I do this, I say integer adjusted pay, and I want to get the integer value of gross pay, then I would do a typecast right here and say int in parentheses, which says take the value here gross pay, convert it to an integer data type, and then store it in adjusted pay. Let's say, for instance, gross pay in this case is 481.75. Adjusted pay will be 481. Now you'll notice it did not round up to 482. Anytime you convert to an integer value, it does an operation called truncation, meaning whatever the decimal value is here, it just gets chopped off and it's gone. And if you want it to round up, you need to use a math function like the round function. Now, math operations in Java, here's how they're designated. You have addition, subtraction, multiplication, division, and modulus. Then, of course, you have parentheses. And then for math functions, you'll actually call the math function you're using. Like, for instance, the power operation here, POW, that's for doing exponentials. And you have the SQRT for doing square roots. Just a couple of sample math functions you can use in Java. And then some examples here of actual math operations. Let's say we have this math formula right here. A equals 4b minus 3c plus 2d. Here's what it'll look like when you convert it to source code in Java. A equals 4 times b minus 3 times c plus 2 times d. Or what if we have y equals 1/2 x minus 2? We have y equals x minus 2.0 parentheses, and then times 0.5. Notice that whenever we do floating point math, that like here is a whole number, but because it's a floating point operation, we actually want to put a decimal place on it so that the program knows that we are trying to resolve floating point values. Then right here, let's say we want to do an operation like this where it's 1.546 times 10 to the 6th power, which is your standard scientific notation. Well, here I'll do converted value. We give the 1.546 and then times, and I'm going to do an exponential operation, so I'll use the power function, and I'll say 10 to the 6th power, and it will calculate that value and then multiply it by the 1.546, and it will give converted value, which is going to be this value converted out of scientific notation into a working value. Now here is a sample program of the differences between floating point, doubles, and then integer operations in a computer when you're doing division. Division in a computer is totally different for floating point operations versus integer operations. The other ones like multiplication, addition, and subtraction will resolve the same for integer or floating point numbers. But when working with division, you get different results. In this particular case, first I give an example with float. And like I mentioned earlier, for doing a float, I have to put the F at the end of my values here so that it knows they're treated as float and not double. Then I have a double operation, again 7 divided by 2. And then I show the integer equivalent of doing division where I get a result and a remainder. And right here shows the screen output where the first operation will be 3.5. The second operation will also be 3.5. And then the third operation will give me the result of 3 and the remainder of 1. So anytime you do integer division, you're actually producing two answers. One is the result value and the other one is the remainder value. Now finally, let's look at an example of creating a little program that can actually utilize a mathematical function. In my particular case, I decided to use this example of converting Fahrenheit temperature into Celsius. And the formula is right here, where you take the Fahrenheit, subtract 32, and then multiply it by 5/9. So we go down here to the working program, and what you will see is, first of all, I prompt the user to enter the temperature in Fahrenheit, and then they will enter the value right there, and that will give me the F Fahrenheit value. Then I go to the mathematical function here, and you'll see I do Fahrenheit minus 32, and that's in parentheses. And then it will be times 5 divided by 9. And of course, using the standard math order of operations, first you will subtract 32 from the Fahrenheit value, And then you'll multiply by 5 and then divide by 9, and then you display the output. And here's what the output will look like on the screen, where you prompt the user, they enter a value, performs a math operation, and then displays the temperature as shown.